Everyone knows that my favorite plotting tool is Matplotlib. But have you ever wondered how it all works? And even more importantly, have you considered what you might gain from just taking a peek under the hood? Well, you're in luck, because today we're going to take a dive into Matplotlib's backend abstractions, learn about its essential components, and apply this knowledge to make some fun applications using Matplotlib. We have so much to discuss. But first, I want to welcome you all again to Matplotlib Without, matplotlib.pyplot. My name is Cameron Riddell, and I will serve as your presenter. Today we're going to take a journey to understand the moving parts behind Matplotlib that makes it work. No, we're not going to talk about artists and containers, though I'm sure these concepts will still come up, but we will be talking all about the figure in Matplotlib and everything that supports it while creating some fun exploratory applications. Let's go ahead and take a dive. Before we dive into a lot of the code, I want to explain to you what I mean by Matplotlib's backend by juxtaposing it against the front end. And no, we're not talking about a backend server and a web browser front end or a React front end like we would with some web applications, but in Matplotlib, we tend to just use this same type of terminology to disassociate, right, the front end, the commands that do the drawing. So these are our abstractions. This could be things like our figure and our axes, as well as the artists and containers, since they are technically both artists and containers themselves. But then underneath of the figure, we dive into what we consider to be the back end. And in the back end, when we dissect the figure, we see that there's a few moving pieces. We see that there's a canvas manager, and there are renderers. And we can understand each of these pieces by just taking a look at what they do, and then we can see how Matplotlib fits together all of this plumbing that makes the tool just work. And that's the best thing about PyPlot, is that it does, for the most part, just work. I can create, a figure, an axis, I can plot whatever I want on it, and then I can use this top level show command and it just works. Easy Matplotlib chart. And so if we inspect the figure, you might do a dir on the figure, you might see that, oh, well, the figure has a .show method. Maybe I'm trying to use Matplotlib's object-oriented API, and I might say, okay, well, I want to use figure.show instead. And you see that when I try to do that, we had something very quickly pop up on my screen, and then it immediately disappeared. So I wasn't able to actually show my figure. So what is it? What's the difference between pyplot.show and fig.show? Well, a quick help on our fig.show reveals to us that, well, we need to be sure that we actually did create a map figure using pyplot.figure like we did already, but if we did not, we are verifying that we might be missing this figure manager base. But what is that? And you see this warning here that this method does not manage a graphical user interface event loop. This is a very key component. Turns out, we want to use Matplotlib in an interactive way. When we call pyplot.show, we are actually starting a graphical user interface. Whether that's going to be tkinter, wxPython, Cairo, depends on the system and what you have set up and what you have told Matplotlib to use. But it's going to be starting an event loop, and then it's going to be drawing onto that canvas or directly onto that graphical user interface toolkit, whatever it may be. And that is what PyPlot is doing for us. It is actually managing the setup, the construction, and deconstruction of two very specific things. It's managing the canvas, which is Matplotlib's abstraction as to where to draw. And then through the canvas, it has intermediated what graphical user interface it's going to be using. And PyPlot also manages the lifetime of that GUI in itself. And so we can actually access the canvas just like this using figure.canvas. We can see that we get this figure canvas tk_ag object. And now the very important part here is tk is referring to tkinter, which is what I'm using for my graphical user interface. And if you've ever created a tkinter application in Python, you can do import tkinter. That's the exact same tkinter. Now the ag here, this corresponds to our anti-grain geometry drawing library. So this is the drawing library, the very low level drawing library, I should say, and it's drawing to a window on tkinter. And so we have the what and the where all stored and managed within our canvas, managed within PyPlot itself. So let's take a deeper look at the portions of this canvas that we have here. If I create a figure, you see that I get our canvas, I get a canvas manager, and then I get a renderer attached to that canvas as well. And so the canvas manages where the drawing occurs. It's a Matplotlib based abstraction, and you can see that we have our figure canvas TK ag here. Then we have our canvas manager. This is an adapter class. If you're familiar with object-oriented patterns, this is an adapter class that allows us to have a more uniform access to our graphical user interfaces, regardless of which one we're using, whether that's tkinter, WX Python, even a web backend. There's a lot of different plug-and-play backends, and the fact that they are decoupled in this fashion really lets us plug and play. I can use the same Matplotlib code and I can have it run in a graphical user interface by any of these backends. And so that's what the manager is all about. It's all about creating a uniform API for each of these backends. Now, it's not guaranteed that it's going to be perfectly uniform. Some backends might have more methods attached to them or different attributes attached to them. And that's where, if you have domain-specific knowledge with any of these graphical user interface toolkits, that you can use those to actually further manipulate your Matplotlib charting. Lastly is the renderer. We're not going to talk too much about the renderer today, but it is another abstraction. And this is what's actually in charge of doing the drawing. This takes its commands, it goes through all of your artists, and the artists know how to draw themselves, and then the renderer is what actually is doing the drawing or executing those commands. So we have our canvas, which is where the drawing occurs when you're using Matplotlib interactively. You have the manager, which is an adapter class for uniform access to the canvas, and then we finally have the renderer. Now, we do have different classes of backends. And I'll break these up as best we can. We have static backends. These are things that we're not going to be needing an interactive, so a graphical user interface for. This is our ag backend, our PDF, and so on and so forth. This is how Matplotlib can render and write to all these different file types without actually displaying your image to a window in front of you before it does that. So Matplotlib can be used in a non-interactive fashion as long as you don't want to use plt.show in order to actually draw it to your screen and show it in front of you. You can write to a file without even using PyPlot, and that is actually very easy. And you can always select the render that you're going to be using. By default, you will be using the ag backend here. And so most often, this is the one you'll be using, even if you don't explicitly set it. But I will say this, when you use that figure.savefig method and you go to save a figure to a file, Matplotlib, because these abstractions are decoupled, the render is decoupled from the canvas itself, it can very easily say, oh, my user inputted a path that ends in .svg, let me use the SVG renderer and swap out the ag renderer in place of this, and then we'll render all this and dump it into the file, or stream it into the file, I should say. It's for a vector-based graphic. Next up, we have the interactive backends. Now, these are not renderers. These are all graphical user interface toolkits. You'll see here, we have our TK ag, and you'll see that most of these are dichotomized in terms of their name. We have Qt ag, This is a PyQt or a Qt graphical user interface that does its rendering using the ag backend. And so interactive backends are often comprised of two pieces here. Next up, the other thing I want to point out is TK-ag, which is what we'll be using primarily today. But there's also NB-ag and web-ag. If you've ever used Matplotlib interactively in a notebook, that means you're using the %matplotlib Jupyter magic, not the %inline, Matplotlib inline, but just the %matplotlib notebook magic. You'll end up using the NB-ag. And then the web-ag is, you can actually open up a WebSocket that leads to the implementation of NB-ag, but this is kind of what's going on under the hood here, so to speak. So you have all these different GUI toolkits that you can use that Matplotlib can actually plug and play. And I must say it's extremely impressive that Matplotlib can link up to all of these different toolkits. And you can think that such a widely used tool, it has to be dynamic in nature. And so they definitely made the right decision here by decoupling the front end logic, right? The composition of all the drawing commands from the things that actually do the drawing and where they're actually drawn to. But let's take a look at an example here. So here, we're just going to take a peek at some of these objects as we change backends. So here I'm using just the default TK-ag backend, and you can swap backends by using matplotlib.use. And it turns out, if I swap this out for just ag, and I strip away the TK components, you see a change in my canvas itself, you see a change in the manager object, but you don't see a change in the renderer here. So what's going on here is that Matplotlib really has this plug and play even at runtime. It can dynamically select which backend to use, which is quite impressive. But one thing I do want to point out, regardless of the backend that I'm using, if I instantiate a figure outside of PyPlot, well, it turns out that we don't actually have a renderer set up because PyPlot takes care of that. We don't actually have a canvas manager set up because PyPlot takes care of that. And we just have the figure canvas base, which is kind of the abstract base class for creating canvases. So we don't even have that fully set up. And it's not an abstract base class in the strict sense where it's unusable. It very much is usable, but this is all of the plumbing that PyPlot takes care of for us. It creates our canvas with the appropriate backend, it creates our canvas manager, and it creates our renderer for us. Now, if I were to actually try and show just creating a figure right from matplotlib.figure without using PyPlot, show does absolutely nothing. Even figure.show would do absolutely nothing. Let's take a look with these different backends. TK-ag, it has a tkinter graphical user interface attached to it. I can use show and my chart works accordingly and it's rendered and displayed on my screen. Ag on its own, I get an error here. Matplotlib is currently using ag, which is a non-GUI backend, right? So ag is just the renderer part of this backend. I have not specified a drawing or a graphical user interface to actually draw to, and so it doesn't actually set up right this canvas or a usable canvas manager that I can actually draw to my screen. And so you can use just the ag mode whenever you're drawing completely non-interactive figures. Say I need to make 100 Matplotlib figures and save them all to disk. Using just the ag without any of the overhead of PyPlot is a great way to go for this. I can use other things. I can use WebAg, for instance. And actually when you use WebAg and you use show here, instead of creating and spawning to your screen a graphical user interface, you actually do have a web interface here. You can see this is just being served. It's on a Tornado application actually. But we actually do have some in the browser interactivity with Matplotlib in the same exact sense that you have pretty much the same layout if you've ever used the NB ag or the Matplotlib notebook magic from Jupyter. And so this is just another example here that we have of how you can really plug and play with backends on Matplotlib. So let's talk a little bit more about the figure manager. This is an adapter class, right, for uniform actions across on the canvas. And you can use these really regardless of your backends, but specific backends might support additional functionality. Taking a look, there's actually not too many methods and attributes here. There's actually a few interesting ones. Create with canvas is a class method for creating these things. But we have destroy, full screen toggle, get window title, and set window title. These are the actual methods that are going to be guaranteed to actually be on the Matplotlib manager instance. And so you can actually use all of these or any of these on any canvas manager. Now, this might sound like a silly application, but if you need to exert control over the graphical user interface that Matplotlib is using, the canvas manager is going to be the place to go. So for example, I can very well create a Matplotlib figure and then I can show it to you. But what if I wanted to automate the full screening of this application? Let's go ahead and take a look at what we have here. Matplotlib figure, it renders, it's beautiful, great. But if I actually wanted to full screen it, well, I could full screen it manually, but I'm being lazy. How else can I full screen it? Well, I can actually reach into the Canvas Manager, and there, for all the backends, will be defined a method called full screen toggle. And this will work on the majority of the backends that Matplotlib has. Now, for this to actually work, I need to actually start this in a thread. I'll have it sleep for 2 seconds, and then we'll hit this show. And in Matplotlib, whenever you hit a show in an interactive fashion, or in a non-interactive fashion, I should say, show will block. So my code will be held up here, but don't worry, this other thread will still be ticking, and we'll actually see if we reach this full screen toggle. Now I'm not going to use any keyboard shortcuts here, and after 2 seconds, you can see that my graphical user interface has full screened my machine. I can do other things, right? I can actually destroy or just cause Matplotlib to show for 2 seconds and then destroy it. You see I get a little error here because tkinter, the event loop that was running, tried to end up destroying itself, and then it said I can't find myself because I destroyed it from externally. But let's take another look at this pyplot, at this Canvas Manager. It turns out there's also a pyplot show method attached to it. And from here, we actually get the same exact behavior of show called from the pyplot module. And so, not too interesting here. We can see it for 2 seconds, it disappears. But let's break this down. If you dive into the code, you actually see that this pyplot show is composed of 2 core elements. It is composed of calling show on the manager. And you remember when I called figure.show earlier, it just flashed up for a fraction of a second and disappeared, and we couldn't hold it to the screen. Well, it turns out we call show to do the initial drawing of our chart to our canvas, and then we start the main loop of the graphical user interface so that my code will effectively pause and enter the graphical user interface event loop. And by doing this, I actually replicate the full functionality of pyplot.show without using pyplot. And then we end up destroying our window because of our thread there. But this is the pattern that we're looking for. This is how we can start to use Matplotlib without pyplot. So I've shown you a lot of examples with pyplot. Let's stop using pyplot already. The easiest way, as I said earlier, is to just use Matplotlib in a non-interactive fashion. Meaning, if you never need to show, then you don't need a graphical user interface. So what I can do is I can use the ag backend, and I can create a figure, I can add a subplot to that, and then I can just save it to file, and I can show you that this actually worked. I never had to call plt.show, I never had to call plt.figure or plt.subplots. There's no pyplot, I didn't even import it here. And let's take a look at the figure that this generated. And so I'll just read that file in my image viewer here, and you can see we get the exact same chart out. So it is very possible to use Matplotlib without pyplot. But why might I want to use Matplotlib without pyplot? Well, if you're ever creating a lot of figures in a tight loop, you just might encounter this error, or this warning, I should say. More than 20 figures, or whatever default you actually have set for Matplotlib, this is saying that figures are not automatically garbage collected. There are strong references held onto each figure through the pyplot interface because of all that plumbing that it sets up for us, meaning our figures will not be deleted. Instead, you actually have to explicitly manage the life cycle or the lifetime of each figure by calling close on it. And we can actually see the difference in these references here. If I don't close any of these, I can grab all of the figures from matplotlib.pyplot using the plt or pyplot.getFignums. You can see I have this list here of figures. If I close these, well, we end up getting rid of those references, so we're actually able to delete the figure. If I just use the figure object from matplotlib.figure, I don't need to worry about cleaning up because they will be automatically garbage collected since there's no strong references to these figures anywhere else. So this is one place where I would say you can use Matplotlib without pyplot here. Let's talk a little bit more about when you might want to do this. When does this come up in a practical application? Well, if you have ever created a web server and then created graphics or visualizations and pushed them to that web server using Matplotlib, this is a great time. Now, I can create a very, very simple Flask application with a very simple HTML body. All it's doing is creating an image tag where I'm going to inject my base64 encoded Matplotlib image. And so I can just save that to a bytes.io object, and then I can simply render that template and then pass that back up to my front end. So In this application, you'll note that I'm not using pyplot, and I've also explicitly told Matplotlib that we should use the ag backend here. And so when we do this, we're not relying on the pyplot plumbing, so I don't need to worry about the lifetime of my figure. You can think, if we ended up working on this figure and say this was an actual application that was serving maybe 100 end users, if everyone hit this website all at once, we would see that runtime warning of pyplot because we'd have generated and kept open 100 figures all around the same time. Now there might be timing overlaps with that, but if we simply use the figure from Matplotlib, we don't have to worry about that lifecycle. We don't have to worry about appropriately closing out this figure using pyplot.close to get rid of those references. We can simply plot our code and keep moving forward. Now I will say there is one drawback to using Matplotlib in this way. If you ever want to check on an intermediary step using pyplot.show, then you will actually have to go and swap this out, right, for a pyplot managed figure through the pyplot interface. So you have to think about the future. Am I always only ever going to be generating Matplotlib figures non-interactively, meaning I'm never going to want to see them until they hit disk? If that's the case, feel free to use the figure object. In all other cases, use pyplot. It'll be more convenient in the future. Now, what can I do with all of this knowledge? We've talked about a lot of the abstractions and moving parts behind Matplotlib. Well, turns out one of the best parts about it is if you know a little bit about the graphical user interface toolkits themselves, or if you want to do something on the web, if you know a little bit about Flask or whatever web application or server you're using, well, you can actually introduce activity. So I'm going to spruce up my HTML here, make something a little more complex. Specifically, I'm going to have a simple range slider here. I'm also going to update my endpoint so that it's a GET request to our index, and I'm expecting an argument or a query parameter here. So just by making this one little change, I actually can re-render this plot, and I can supply, right, a query parameter here, and I can link that query parameter up to this widget that you now see on my screen. And if I move this widget, this will actually change the power function that is used to calculate and draw this chart. And so you can see here, this is x squared, this is x cubed, this is x to the fourth, x to the fifth, and so on. And so this is a way that we can dynamically generate and interact with Matplotlib just by using a little bit of its own backend along with it. And now we're not showing off a lot of the backend here, right? We're just showing off not using pyplot. But what if we want to talk about actually running a native Matplotlib application without relying on pyplot, and we can start to ascertain what all convenience is pyplot doing for us? It turns out, well, pyplot's doing quite a lot. But if you're familiar with tkinter, I can create my own tkinter application like so. I can set a title on it, and then here's the best part. I can create my own figure canvas. Now I'll have to obviously make sure that I select the correct one, aka one that's tkinter compatible here. And then I can simply pass in the figure I've created, and I can give this my application. I could give this a window, but in this case I'm just giving it the root of my application here. You can force that canvas to draw itself, and then what you'll want to do is finally actually pack that widget or the canvas onto your tkinter application. If you're not familiar with laying out things in tkinter, right, you'll always be packing or adding things onto a grid here to actually render them to view. Finally, we call the main loop of our application, and I'll comment this out for now. But we see that we do, in fact, get our Matplotlib looking application. This is actually a tkinter application with a canvas in it rendering a Matplotlib graph. That's exactly what pyplot is doing for you. Now, this is a very simplified version. You'll see, I actually have to close this out manually by hitting the X button. Well, with our tkinter applications, right, we can always bind keys or actions to our keys. So if I want to delete this window with my button of a Q press, well, I can do just that just by linking it up. Now, Matplotlib does expose this functionality to you. It does expose a lot of different things that you can bind to events emitted by the graphical user interface loop. It will actually intermediate this for you so that you have a uniform set of events being emitted that you can respond to as well. So if you ever want to make a very highly customized and high touch graphical user interface that is powered by Matplotlib, intermediated to another graphical user interface, you absolutely can. But here I wanted to show you a lot of the conveniences that Matplotlib has set up. Just by looking at this application, well, first I showed you that I have to manually specify, right? If I want Q to actually close the window, I have to specify that. You see that in regards to a regular Matplotlib interface, I'm missing that toolbar that allows me to interact with my figure, maybe drag it around or zoom in. So that's another very important feature of that PyPlot brings to us pretty much for free, regardless of the backend that you are using. Now, let's make a more fully featured interactive application. With just a little bit of tkinter here and not too much Matplotlib, right? We can instantiate our Matplotlib figures and our axes. We specify a function that's going to be called on a callback here. And so all we're doing is we're just going to update where our line is in data space. You can think this type of approach, this interactive approach, could be very useful for a lot of data exploration. I'm going to use it here for a space exploration or a functional space exploration, but all we do is set up our canvas just as we did previously, and now I just need to specify some widgets at the tkinter level. I'm going to have a wavelength parameter. You can think I'm playing around with sinusoidal waves here, and so I'll have a wavelength widget here. And then I'm going to have an amplification, or an amplitude, I should say, an amplitude widget here. Now they're going to be right next to each other. And then I'm going to pack them all into my tkinter widget. Then I'm finally going to pack that canvas onto tkinter widget just below, right where I put those control widgets. And then we set up our standard main loop here, and we create our tkinter application. And you can see I have widgets on the top of my screen. I have my actual Matplotlib visualization in the center. And as I change my wavelength, you can actually see the corresponding update in my Matplotlib figure here. And so this is a very simple and intuitive way, in my opinion. I'm familiar with tkinter. This is a very simple way to create interactive charts, specifically interactive charts with intentional interactions, not just the default things that Matplotlib will give you as part of its toolbar, but very custom interactions that you can create using Matplotlib. And this is one thing that really grinds my gears is when I hear people say, oh, well, I'm going to use Plotly, or I'm going to use Bokeh because I need to have interactivity in my chart. And I'm sitting here, I'm like, you can get interactivity in Matplotlib. The things that Bokeh and Plotly give you is that you get interactivity on the web where the drawing is done on the front end. Whereas with Matplotlib, you would have to do the drawing on the back end and then pass those updates, or actually pass the brand new image up to the front end. So you end up passing a lot of data back and forth. And that's why it's more so better for local applications like we can see here, because I can very quickly, this is going to be much more snappy than anything based in the browser by using a native application like this. So let's talk about our takeaways here. I'm not saying don't use PyPlot. Please do use PyPlot. It's extremely convenient to use, and it lets you just focus on the plotting. You don't have to worry about all of the GUI toolkit, the backend, or all of the plumbing set up to actually make Matplotlib draw to a specific graphical user interface. The Canvas Manager is really useful when you're issuing common commands to interactive backends. So things like changing the size of the window itself, or embedding that window into a broader application and linking their event loops. You can do that all through the Canvas Manager, which you can access right through the PyPlot interface, which is quite nice. But I will say this, you do not need PyPlot when you are working with Matplotlib in a completely non-interactive fashion. That's all I'm doing is creating a figure, some axes, and then I'm just writing that to file. I don't want to look at this using a show in between. Or you need to exert some manual control over the graphical user interface framework. These are the two times that you do not need PyPlot. And I will say this, right? If you do intend, or you're uncertain if you need to work with a chart in an interactive fashion, just use PyPlot. It'll help you reduce that future ambiguity of, oh yeah, I just need to dump this to a file and it's going to be fine. And then a month later, you start looking at the files, you're like, oh wait, I've been creating very good visualizations. Maybe I should intersect this, or maybe I should intermediate and check what's going on, on every now and then. that's when you might want to keep that PyPlot code around, because it will help you create those intermediary visualizations so you can just see and help debug maybe what has gone wrong. But that does take us to the end of our session today. I want to thank you all for coming, and I want to make sure that you are ready for our upcoming seminar. So make sure that you stay tuned on Twitter, on LinkedIn, on Discord. And of course, if you do want the code for this session, all you need to do is go on Discord and ask. Thank you very much for attending, and I hope to see you again real soon for our next seminar.